Chapter 7, Similar Polygons. Today we're going to cover Section 7.2, Day 2. Your class opener. Which proportions are equivalent to x over 12 equals 3/4? Okay, use the proportion a over b equals 3/5 to complete each statement. And again, I tend to think of the cross multiplying for these. So for number 1, when I see 5a, I'm thinking they cross multiply to give me the 5a. So if I'm cross multiplying the other direction, I should get 3b. Okay. The next problem, number 2. If I look at the fraction on the left, it used to be a over b, now it's a plus b over b. So all they did was they added the denominator up into the numerator. So if I do the same thing with the fraction on the right, adding the denominator up into the numerator, I'd get 3 plus 5 all over 5. And if you want to combine it to 8 over 5, that's okay. Number 3, I see that I have 5 over b is going to equal something else. Well, I sort of noticed that it's a 5 over b, which is like the 5 and the b on the bottom. So it's almost as if they just took the proportion and they rotated it. So if I tend to do the same thing, I think of that, the 3 and the a should go on this side. Well, since the 5 was up on the top, then the 3 should also go up on the top. And since the b, the part on the left, was in the bottom, then the a, the part on the left, is on the bottom. And I can even sort of double check. If I cross multiply the original problem, I get 5a and 3b. And if I cross multiply my new problem, I'm going to get 5a and 3b. Number 4. Let's see. So they're giving me 5/3. Well, if I sort of look, that's just, they took the original fraction on the right and flipped it upside down. So all I'm going to do is take the original fraction on the left and then flip it upside down. So it should be b over a. And it's an easy double check again. The original problem, if I cross multiply, I get 5a and 3b. And my new problem, I also get 5a and 3b if I were to cross multiply. Find the value of x. So cross multiply. So if I start with my x times 7, I get 7x equals, cross multiply in the other direction, 3 times 5 should give me 15. Divide each side by 7, and I notice it doesn't come out nice and it doesn't reduce, so I'm just going to leave it as 15 sevenths. Cross multiplying the next problem. I'm going to start by multiplying the 4 times the x minus 2, so I make sure I distribute and get 4x minus 8 is going to equal what I get when I cross multiply the other direction, which is just 3 times 1, so that's a 3. Solve the equation, I'd add an 8 onto each side, which is going to give me 11. Divide by 4. Here's another problem that doesn't reduce, so I just get 11 fourths. Number 7. I'm going to cross multiply, and I'm going to pick these to start. Well, this is where I really have to think of the whole, how do you multiply an x minus 1 times an x plus 2? So I have to go through and do the whole FOIL. First outside, inside, last. Or I can think of distribute. First I'm going to take the x and distribute it in. X times x is x squared. X times 2 is 2x. Now distribute the negative 1. Negative 1 times x is minus 1x. Negative 1 times 2 is minus 2. And this is going to equal what I get when I cross multiply the other direction. So you can think of the whole FOIL process again, or you can just think of let's distribute. I'm going to take the x and multiply it up into the top. So x times x is x squared. X times 4 is 4x. Now multiply the negative 2. Negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. And if you remember back when we did these problems before, the middle two terms typically get combined together. So if I combine them over on that left, I get x squared minus 2x, plus 2x minus x is just plus an x. On the right side, if I combine, 4x minus 2x is 2x. And now I need to solve this equation. Well, I notice if I subtract an x squared on each side, they're just going to cancel out. So now I'm left with this simpler problem. I'm going to actually subtract an x on each side. So if I subtract an x from the left, I get minus 2. If I subtract an x from the right, 2x minus x is just an x. Now I'll get rid of the minus 8, so if I add 8 on each side, I get 6 equals x. Doing these same steps over on the right. And it looks like it might be a little bit easier over here because if I just multiply in the 9, there's not as much to do. 9 times x is 9x. 9 times a minus 1 is minus 9. And now I need to multiply the other way. So you can think of the whole FOIL again, or just distribute. I'm going to multiply the x coming down this way. X times x is x squared. X times minus 3 is minus 3x. And now I'm going to multiply the 3 going down. So 3 times x is 3x. 3 times minus 3 is minus 9. Okay. As I go through, I notice there's nothing to combine on the left side, but on the right side there's this minus 3x plus 3x, which is just going to cancel out. So that part's sort of gone, and I'm going to be left with 9x minus 9 equals x squared minus 9. Well, let's see how we would solve this one. I notice there's an x squared that's not going to cancel, so let's get everything to the same side. So I also notice that there's a minus 9 on each side, so if I add 9 on each side, the minus 9s are going to cancel. So I'm going to subtract 9x on each side and get 0 equals x squared minus 9x. Since there is an x squared in here, I'm going to have to factor this to solve it. And hopefully you remember the first thing you should check for factoring is, do they have anything in common? And I notice these both have an x in common. So if I factor out an x, I get x minus 9. Okay. Well, I have two quantities that multiply to give me 0. If two quantities multiply to give me 0, then one of these quantities must be 0. So let's check. So either the first quantity equals 0, and there's an answer, x equals 0, or the second quantity equals 0, and I get x minus 9 equals 0, and I can solve that one by adding 9 to each side. So it looks like I have two answers of 0 and 9, and the only thing you really need to do is you need to check one last thing. Before you keep each of these answers, you have to check to make sure that they don't make a denominator go to 0. So back up in the original problem here. If I substitute in 0, I get 0 minus 3. Doesn't make the denominator go to 0, that's okay. If I substitute in the 9, I get 9 minus 3, which is 6. Doesn't make the denominator go to 0, so I can keep and use both of those answers. If I would have, say, gotten an answer of x equals 3, 3 minus 3 would make the denominator go to 0, which doesn't exist, so I wouldn't be able to use that answer. Next problem. In the figure, AD over DB equals CE over EB, and they want us to find some missing values. So if I sort of look at where these are coming from, here I have AD and DB. So AD is the shorter piece, and DB is the next segment in line. If I look at the other side, CE and EB, I get CE is the short piece, and then EB is the rest of that. All right, so let's fill in. For number 9, I don't know how big AD is, but I'm going to start writing the information over in the diagram. They tell me that DB is 8. They tell me that AB, the entire piece, is 10. Well, right away, if I know the entire piece is 10 and DB is 8, I know that AD, the smaller piece, is going to have to be 2. So I'm going to fill that in my chart right away. They give me CE, I don't know. EB is 12. Right. So let's try to set up a proportion to figure out our missing part, CE. And I don't know what CE is, so I'm going to call it X. So now I'm going to look up here at my original proportion and fill in the pieces I know. So for number 9, do I know AD? I do. AD is 2. Do I know the bottom DB? I do. That's going to be 8. Equals. Over on the top right, CE, I don't know how big that is, but we've decided to call that X. And the bottom right of our proportion is EB, and we know that that's 12. So here's our proportion to work with. And I'm going to look and notice that I can reduce between the 2 and the 8. Don't reduce between the 2 and the 12 because there's an equal sign in the middle, but I can at least reduce between the 2 and the 8 and reduce it to 1/4. So if I cross multiply from here, I get x times 4 is 4x. Diagonally, 1 times 12 is 12. Divide by 4, and x equals 3. So CE is 3. Well, and if I know CE and EB, 3 and 12, add them up is 15. So CB is going to be 15. Let's do number 10. So we'll erase the information out of our diagram and fill in the new stuff. So let's see for number 10. AD is 4. Oops, more apart. So AD is 4. DB is 12. And right away I know if that's 4 and 12, the entire piece is going to have a length of 16. So let's write in that AB is 16. Looking at the next part, CE I don't know. EB, okay, I don't know EB either, but I know that the entire piece is 20. Well, if CE is 20 and the entire piece is 20, EB is going to be 20 minus x. And now let's fill in our proportion. So our proportion, if I look up at the original problem here, it says AD is the top left, and AD I know is 4. The bottom left is DB, which I know from the chart is 12, equals CE in the top right, and we said from the picture that CE is x. And then my proportion tells me the bottom right is EB, and if I look at my diagram, EB is 20 minus x. Looking at my fractions again, I can reduce the 4 and the 12. They're both divisible by 4, so I can get 1/3. And now if I cross multiply. So I'm going to take the 3 times x first. So 3 times x is 3x. Multiplying the 1 times a 20 minus x is still just 20 minus x. Add x onto each side, and you get 4x equals 20. Divide by 4, and x equals 5. And then if I look at my diagram, if x equals 5, I know CE is 5. Fill that in my table. EB is 20 minus 5, which gives me 15. And I'll fill that in my table as well. And your closure. The most important part of solving a problem is